Hyperbolas. So they've got a couple of different forms they can take. We can have them looking like that, where the asymptotes are the coordinate axes, and that takes the form y equals c squared over x, some value of c. You can rotate the whole thing round and you get something with the form x squared minus y squared equals k, which looks a little bit more like that. So a reflection in the y-axis, effectively. For the general form, x squared over a squared minus y squared over b squared equals 1. The centre's 0, 0. It cuts the x-axis at plus and minus a. So whatever this value is on the bottom in your equation, you're going to want to square root it. Okay, so that's the two places that it cuts the x-axis, here and here. It doesn't intersect with the y-axis at all, and the asymptotes are of the form plus or minus b over a x equals y. In the formula book, it's written in as x over a equals plus or minus y over b. If you rearrange that by just taking the b over to the other side, then you get them in this form effectively. So worth remembering this whole b over a x part, because asymptotes is generally the first thing they ask you. So what I'm going to do is go through a couple of questions on hyperbolas just so you can get an idea of the kind of things that they might ask you in the exam, and we'll check that we understand what's going on as we go through. So, first question. Diagram shows the hyperbola x squared over 4 minus y squared equals 1 and its asymptotes. Write down the equations of the two asymptotes. Well, we know how to do this. We're going to take this and we're going to look back at our general form, which is given in the blue booklet, but also on here we've got x squared over a squared minus y squared over b squared equals 1. And remembering cutting the x-axis at plus and minus a. So we're going to rewrite over here just for comparison. Which means that we've got a is equal to the square root of this, which is 2, and b, because there's nothing there, we're going to presume that's a 1, because 1 squared will still be 1, and that's what happens when you can't see 1 over here. So the equations of the two asymptotes we said were plus or minus b over a x, so y equals plus or minus 1 over 2 b over a x. So they're your two equations, y equals a half x and y is minus a half x. Looks about right if you look at the diagram, that could be about half x and minus a half x. The points on the hyperbola for which x equals 4 are denoted by a and b. Find in third form the y-coordinates of a and b. So we're looking for the y-coordinates. We know how to find the y-coordinates by relating it to all of this. So let's work our way through and see how we get on with finding our coordinates. So if we go back to our original equation, and this time we bung in the x value of 4, so we'll go 4 squared over 4 minus y squared equals 1. Well, that's 16 over 4, which we know is 4. In fact, let's leave it for now. Let's leave it as 16 over 4, and we'll fix that in a minute, because I think we're going to need to do a bit of rearranging. Probably easiest to do that first. In fact, no, let's go 4 over 4 minus y squared, 16 over 4 is 4, sorry, minus y squared equals 1. So we're going to get, if we take the y squared over there and the 1 over here, we're going to get 3 is equal to y squared. So y is equal to plus or minus root 3. Don't forget the plus or minus, because obviously if you square plus root 3, you'll get 3, and if you square minus root 3, you'll still get 3. So this plus or minus is really important. If you'd have just got one of them, then you'd have ended up a little bit confused, because you're not going to know what the other one is. It's usually fairly obvious, and obviously it's symmetrical about this x-axis, so plus and minus root 3. So we're finding the y-coordinates of a and b. Y is plus or minus root 3. Obviously you'll do your working out in a slightly more logical place than me, but hey. The hyperbola and its asymptotes are translated by 2 units in the positive y direction. Write down the y-coordinates of the image points under this translation. Well, if we're translating it by 2 units, then it's going to be root 3 plus 2 and root 3 minus 2. So that would be our two answers to that. Y equals, let's go with 2 plus root 3 and y equals 2 minus root 3. So they're going to be our two values, just because it's a translation of 2 units in the positive y direction, so we're just going to add 2 units to the y value. The equations of the hyperbola and the asymptotes after the translation. Well, we know that if you translate it 2 units in the positive y direction, you're going to be replacing y with y minus 2 in your equation. So we're just going to take the original equation again, which was, we decided x squared over 4 minus y squared equals 1, only we're going to replace the y squared with a y minus 2. So we're going to have x squared over 4 minus, and where it was y squared, we're going to need to replace the y part with y minus 2, so we're going to make sure we square all of that. Like that. So that's the equation of the hyperbola after the translation. We're then going to look at the asymptotes. So the asymptotes were y equals plus or minus a half x, we decided, from up here, because that was our plus or minus b over a x. So if we're translating the y value by 2, we're going to replace this with y minus 2, because plus or minus a half x. So we might as well take the 2 over to the other side and make it y equals 2 plus or minus a half x. So that's the equations of the asymptotes after the translation. So it's not as hard as it looks. We don't usually like the look of hyperbola questions, but it's not actually that bad when you work your way through. It's just a little bit of translations of graphs and knowing what it does. And if you can remember this plus or minus b over a part for the asymptotes, then everything else has been pretty easy, I think. So let's have a look at another one and see whether we get on as well with that. Okay, so this time we've got an equation x squared over 9 minus y squared equals 1, and we're finding the equation of the asymptotes. So let's compare this with the general form. So that means our a value, if a squared is 9, then our a value is going to be 3, and there's nothing underneath the y, so we're going to presume it's a 1. So the equation of the asymptotes we said was y equals plus or minus b over a x. So it's going to be plus or minus a third x in this case. Okay, let's do that over here. Y equals plus or minus a third x. So they're your asymptotes for that equation. For the hyperbola h. The asymptotes are shown in the diagram opposite. It's not actually opposite, it's underneath. On the same diagram, sketch the hyperbola, indicate on your sketch the coordinates of the points of intersection of h with the coordinate axes. So we know that it goes through at plus and minus a, so we know it's going through at plus and minus 3. So we're going to need to mark in our value of 3 and our value of minus 3, and we know that it's one of these ones that's in this form, so it looks like this rather than like this, because it's in this form rather than this form. So we can draw that one in now, like so. Okay, dead easy. And there's no intersection with the y-axis, so we don't need to mark that. We've marked our coordinates. In fact, it says indicate the coordinates of the points of intersection. So let's do them as proper coordinates. Minus 3, 0 and 3, 0. So that it's nice and obvious. You've always got to check that. If it says coordinates, write them as coordinates. Nice easy 3 marks, that one. It's now translated by a vector minus 3, 0, so we're replacing our x with x plus 3. Okay, because it's a minus, so we've changed that over. So the equation of the translated curve is we're just going to take the original equation and we're going to replace the x with an x plus 3. So we're going to get x plus 3 all squared. Don't forget about the all squared part. You're squaring the x up here, so you've got to square the whole x plus 3 that you've replaced it with. Over 9 minus y squared equals 1. So that's the equation of the translated curve. And calculate the coordinates of the 2 points of intersection with the line y equals x. So what we're actually going to do there is we are going to make them equal, and then, in fact, yeah, we're going to make the y squared into an x, because if it's intersecting with the line y equals x, then we know we can interchange the two things. So if we make it all in terms of 1, we can solve it nice and easily. So we're going to make it x plus 3 all squared over 9 minus x squared equals 1. And then we're going to do a little bit of rearranging. So we've got x plus 3 all squared equals, I'm going to do, jumping a couple of steps because I figure you can probably cope with the algebra if you're doing further maths. So I've just taken the x squared over there and then I've multiplied by 9, and then we're going to do a little bit of multiplying out. So I've got x plus 3 all squared is x squared plus 6x plus 9, and then that's going to be 9 plus 9x squared. Getting into my diagram now, which is slightly unhelpful. Doing a little bit of rearranging, I've got 9x squared take away x squared is going to give me 8x squared, and then I'm going to have minus 6x, and then 9 take away 9 will disappear. So I know I can factorise that into, let's just go with x and then 8x minus 6 for argument's sake. So we're going to go with either x equals 0 or x equals 6 over 8, which is 3/4. So our coordinates of the point of intersection with the line y equals x, it's not going to be at x equals 0 because then we're here in the middle. In fact, no, I lie, it's the translated curve we're talking about. So we've got our 2 points, x equals 0, x equals 3/4, but they want the coordinates. Bear in mind if we're intersecting with y equals x, then obviously the x coordinate and the y coordinate are the same, so we'll have 0, 0 and 3/4, 3/4. Okay. From your answers to part C, deduce the coordinates of the points of intersection of the original hyperbola with the line y equals x minus 3. So this one is, we're talking about the original equation up there, and we're looking at the line y equals x minus 3. So x has been replaced with x minus 3, which means it's a translation of 3 units across with the x. We're not changing the y's at all. The y bit isn't moving, so we're just going to worry about the x's, which means if we're moving our thing 3 units in the positive direction, we just need to add 3 to the x coordinates of both of these. So we would get 3, 0 because the y coordinate doesn't change, and 3 3/4, 3/4, and they're your 2 bits. So we've just added on 3 because that is what the translation is doing. It's changing the x's, it's not changing the y's. Okay, so that's another one. Again, nothing too complicated in there, it's just making sure that you've got your head around exactly how the hyperbolas work. So, last one.